Hi, today, as part of Assignment 3 on the multidisciplinary nature of engineering, we'll be talking to you about bionic members. Bionic members are, to put it simply, artificially made body parts that strive to mimic the functions of normal human body parts. Their main function is to help people who, for whatever reason, are missing some limbs. The first instances of prosthetics can be dated back to around 2800 BC in ancient Egypt and Iran. Back then, prosthetics were nothing more than simple statics replacements made from wood or metal. These prosthetics were often cumbersome and offered truly little control for the user, making them poor replacements of the user's lost limb. Nowadays, thanks to the advancements in both medicine and technology, the types of prosthetics we have at our disposal are much more complex, allowing the wielder to have greater dexterity of their artificial limbs, as well as being more cosmetically attractive. The most recent technological advancement to further improve our current prosthetics is the use of bionic technology. Bionics combines biology and electronics to study mechanical systems that perform the same functions as living organisms or parts of them. Thanks to this new field of technology, engineers and doctors are revolutionizing the field of prosthetics. One branch of prosthetics utilizing bionics is myoelectric prostheses. By sensing the strength and frequency of the electrical signals sent by the wielder's brain to the remaining muscles of the limb, myoelectric prostheses can move with much greater control and precision than purely mechanical ones. Another branch in development is osseointegration. This, this branch uses a more intrusive approach by connecting the prosthetic limb directly to the bone with a titanium implant in order to provide greater stability and control while also rendering the weight-bearing responsibility back to the bone of the limb. While these branches are promising, there are still many challenges left to overcome for both engineers and health professionals. To be able to realize these complex bionic prosthetics, the knowledge and experience of multiple different fields are required for all stages of development. When it comes to the design of bionic prosthetics, software, and material engineers need to work with medical professions to fully understand both the functionality and the method of insertion of the prosthetic limb. Software engineers will need to understand what inputs the wielder can send to control the prosthetic limb, whether that be through electrical signal from the brain or the small movements of the remaining muscles of the limb. Bioengineers, thanks to their background in biology, will have a general knowledge of the functionality of both the limb and how the body reacts with foreign objects. They will also be able to manipulate certain biological processes happening within the user to better integrate the prosthetics with the host. With this additional knowledge, bioengineers and medical professionals will be able to effectively communicate on the implications of certain design choices. Finally, material engineers will need to understand how certain materials react with the human body as well as find materials that can perform similar roles as the ones they're replacing. For example, when designing a bionic prosthetic that utilizes osseointegration, using titanium foam as opposed to regular titanium allows the prosthetic to better attach to the bone, which itself is spongy in nature. When it comes to the implementation of prosthetics, the previously mentioned engineers must communicate with medical professionals so that both sides understand how the limb can be installed and maintained. If the integration of the limb requires surgery, the surgeons will need to understand how the prosthetics needs to be attached for it to function properly. If the prosthetic requires training and rehabilitation, physical therapists will also need to understand how to work around the new appendage. Finally, if the prosthetic is to be used on children, pediatricians need to plan replacements as the child grows. So in conclusion, prosthetics have existed since the dawn of civilization, and thanks to the combined efforts of professionals from multiple disciplines, their ability to change the lives of amputees continues to grow. From people born with birth defects or victims of unfortunate accidents, the multidisciplinary field of prosthetics helps individuals reach their goals through functional and cosmetically pleasing appendages, one innovation at a time.